Welcome everyone. Today we're looking at basic area formulas, and throughout the course of this lesson, you should be able to determine the area of a rectangle, a square, a parallelogram, a triangle, a trapezoid, a kite, a rhombus, and circles. Okay. At the same time, we'd like you to be able to then determine the area of composites. So where you have multiple shapes put together, then you're going to find the area of each piece and then combine them. Now, hopefully you guys remember learning most of these formulas earlier. There is a formula sheet that was provided for you. Whether you print that out or you just have it open with you as you work through the problems, it certainly will help. For those of you who like to take notes, you're more than welcome to pause this video at any point and write down the formulas as we work our way through them. So step number one is we're just going to go through each formula with examples or with drawing, showing you guys exactly what is what in them, and then we'll do a couple examples at the end. So we're going to start off taking a look at rectangles and squares. The area of a rectangle is base times height. I know a lot of you may have learned this as length times width as a kid, but we've switched it up and we're focusing on base times height now. Okay, so if you look at a rectangle, you have a height and you have a base. Okay, with a rectangle, it's pretty straightforward. It actually doesn't really matter which one is the base and which one is the height, just as long as you make sure you keep them straight as you're going through and doing any problems. For the area of a square, because both the base and the height are the same on a square, it is just simply a side squared, because when you would do base times height, it would be s times s, which gives you s squared. On to parallelograms and triangles. Now, parallelograms, you're going to find it's the same base formula of base times height as a rectangle. The big difference here is on a parallelogram, because of the fact that you don't have 90-degree angles in the corners all the time, that means you need to get that 90-degree angle to figure out that height. So you need this 90-degree angle right here, okay, to get a height, because the height is the distance between the two bases. Okay, at when you have a line drawn at a 90-degree angle from one to the other. So our base again is just going to be one of these, and then our height is going to be this 90 degrees. So this slanted one doesn't matter. It's only the height, which is the one at 90 degrees that you're looking for. For the area of a triangle, okay, our area is going to be 1/2 of base times height. And so when we draw out a triangle here, again, right, our height is going to be this measurement that has that 90-degree angle drawn. Okay, so we have our base triangle here. We had to draw a line from one vertex to the opposite side with a right angle. Okay, so that way we can determine the height of that triangle. The base is just the side which that intersects at 90 degrees. So again, it's 1/2 of the base times the height. Trapezoids and kites. Trapezoids, right? With a trapezoid, remember you have one set of parallel lines, and those parallel lines are known as the bases. Okay, so we have our base 1 in base 2. Again, it doesn't really matter which one is base 1 and which one is base 2, just as long as you assign one value to one and one to the other. And then again, the height has to be this line drawn at 90 degrees. Okay, if it's not that 90-degree height, then it really isn't a height. Okay, it has to be from one base to the other. Again, the bases are the pair of parallel sides. Now this one is drawn with quite a bit difference in size, but if this one was 21 and this one was 20, this would be a trapezoid and not a parallelogram, because the bases wouldn't be the same size. Okay, kites, this might be the first one that you might not be as familiar with. So with kites, it's 1/2 of diagonal 1 times diagonal 2. Now, if you remember, a kite is exactly what it sounds like. Think about an old school kite. Okay, you have these two sides are the same length. You have these two sides that are the same length. Okay, and I've drawn in these diagonals already because they're necessary to find the area. You need to know the lengths of those diagonals. So diagonal 1 is the entire distance across here, and diagonal 2 is the entire distance across here. One of the things that oftentimes happens is that you'll be given a value here, and you have to remember to double it to determine what it is over here for a kite. If it is for the long side, right, the longer one of a kite, the longer diagonal, is not split in half. So normally there you're going to need both dimensions. Now the only time that that's different is if they specifically tell you that the diagonals are, and then they give you set values. When we go to rhombuses, it's the same exact thing. Okay, it's 1/2 of diagonal 1 times diagonal 2. Right? A rhombus is similar to a kite, except with a rhombus, right, they both get cut in half. So these two pieces are congruent, and these two pieces are congruent. So we have 1/2 of diagonal 1 times diagonal 2. And then a circle, diagonal 1 and diagonal 2. For a circle, right, we have area equals pi r squared. So the only value we need here is r, which is the radius, which is this distance from the center of the circle to the outside edge of the circle. And remember, anywhere on that circle, right, the radius is always going to be the same. Now, I know I kind of went through that quickly, so if you need to go back and take a look, feel free to do that. Also, in Khan Academy, there are lots of videos where there are lots of examples. If you'd like to see more on a specific one, there's also questions that have been assigned to you that you can look at on Khan Academy to get some practice. Okay, so let's take a look at a couple of composites. So here we have a triangle, okay, on top of a rectangle. So that means we need to find the area of this triangle. We need to find the area of this rectangle. And then from that, we can then determine both of them. So we are going to go ahead and we're going to start with our triangle. And if we remember, it's 1/2 of base times height. Now, this particular one, it says we have this height right here, which is very clearly labeled as 4 feet. And we have this, which is 8 feet. Now, I will admit that this drawing can be a little tricky to understand because the fact that you could say, well, is this 8 feet all the way across, or is it just 8 feet for this part? Well, I'm going to tell you right now it's 8 feet for this entire distance all the way across. Okay, so this is a 4-foot height with an 8-foot base. So we just simply put those values in for B and for H, and we take 1/2 times that base of 8 times the height of 4, which gives us 16. We then can move on to our rectangle, which the formula for a rectangle is base times height. In this case, I assigned the base being 4 and the height being 12. So then the area of that is just simply 4 times 12, which is 48. So I found that this top triangle has an area of 16. This bottom base area has an area of 48. So if I want to know what the total area of this figure is, I just simply have to add those two together. So 48 plus 16 is 64 feet squared. Hey, look at that, feet squared. So if you don't remember, whenever we're talking about area, right, which is the amount of space inside of a shape, we have to remember that it is a 2-dimensional measurement. So we want to give it a measurement in units squared, okay, or square units. So this is 64 square units, okay, is what would fit inside of this shape. Okay, when we look at composite 2 here, okay, here we have this, I mean, it kind of looks like you could have 3 different shapes here because this line's already drawn in, right? But this is actually a trapezoid because we have a base here, we have a base down here, we're given a height, so we have what we need for a trapezoid. And then this is a half circle. Okay, so with this one, let's start with the trapezoid. Okay, and our formula for a trapezoid is area equals 1/2 times the height times B1 plus B2. So we have we just put in these values, right? Our height is going to be this 7, right? Base 1, I'm going to make 6, and base 2 is going to be 14. I just picked 6 for 1 and 14 for 2 because 6 was on top, so I made it 1. But it honestly doesn't matter which one is which. So now when I figure out that area, that means I have to do 1/2 times 7 times, and then in parentheses, 6 plus 14. Make sure you do that in parentheses. Otherwise, your order of operations will get screwed up and you'll get the wrong answer. So if you take 1/2 of 7, that's 3.5. We multiply that by 20, and that gives us 70 for our answer. So that gives us this large trapezoid. Now we have this circle up here, but it's only half a circle. So that means that if a regular circle is pi r squared, then half a circle would be pi r squared divided by 2. So we just simply have to put in our r value, and if this is 6 all the way across, that's our diameter. The radius is halfway across, so we just do 6 divided by 2, and we get that our radius is 3. So that would just give us pi times 3 squared divided by 2, which 3 squared is 9, and then 9 divided by 2 gives us 4.5 pi. Now when we go to bring these together, for a total area, we add those 70 plus 4.5 pi. Okay, you could leave it that way, inches squared, or what we'll have you do for these particular problems in your lesson and in your assessment is you'll put in 3.14 for pi, so 4.5 times 3.14, and then you're going to add 70 to that, and it gives you 84.13 square inches. For our final example today, we have this rectangle here, and then right next to this rectangle, we have this lovely rhombus. Okay, so we have to find the area of the rectangle, we have to find the area of the rhombus, and then we have to add those two together. So the rectangle is the easier of the two shapes, so we'll start with that one. Okay, we have a base, and we have a height here of 8 and 22. So to figure out the area of that space, we're just simply going to do 8 times 22, and that gives us 176. We then need to figure out the area of this rhombus over here. So the area of a rhombus is 1/2 of diagonal 1 times diagonal 2. Now here, right, the 7 appears to be this side, the 5 appears to be here, and with a rhombus, right, they're cut in half. We're not specifically told that that's that entire distance, so we're going to assume it's only the half that it's on. So that means that our diagonals are actually 10 for the shorter one and 14 for the longer one. So our area would be 1/2 times 10 times 14, which gives us 70. So if I want to know what the entire area of that composite is, that would mean that I would just simply have to add the 176 from the rectangle to the 70 we got for the rhombus, and that gives us a total of 246 centimeters squared, or square centimeters. So hopefully that is helpful. This kind of brought back some memories of learning this in the past. If you have more questions, like I said, there are lots of other videos in Khan Academy that can help you through these. Also, feel free to contact me if you need some help. Okay, there are practice problems that have been assigned to you guys on Khan Academy, so please take advantage of those and practice through them, and then your summative assessment here in Schoology. Again, if you need any help, don't hesitate to ask. That's what we're here for. Hopefully you're having a wonderful week, and we look forward to hearing from you. Thank you very much.